Recall that a polynomial function of degree n can have at most n real roots. Real zeros can be rational or irrational. Today, we're going to be talking about rational zeros. The Rational Zero Theorem says that if a polynomial has integer coefficients, integers are numbers like -3, -2, -1, 0, 1, 2, and so on. I'm not talking about decimals here. These are integer coefficients. So for example, a polynomial with integer coefficients can be something like this. Okay? What this is saying is, if you have a polynomial with integer coefficients, then every rational zero of the function has the following form. It can be written as a fraction, p over q, where p represents the factors of the constant term. So for example, this is your constant term over q, and q represents the factors of the leading coefficient. So this is your leading coefficient, the number in the very front. That is your leading coefficient. So let's look at an example. Let's try to put this into practice. So using the Rational Zero Theorem, I'm going to list all the possible rational answer choices I can get. So the factors of 1 are just 1, because 1 times 1 is 1, and -1 times -1 is 1. The factors of q are 1 and 4, because 1 times 4 is 4, -1 times -4 is 4. Also, positive and -2. 2 times 2 is 4, and -2 times -2 is 4. So that's how we come up with these numbers p and q. So that means I'll have 1 over 1, which is just 1. I'll have 1 over 4, which is just 1/4. And I'll have 1 over 2. So these are my possible rational zeros. So what this means is if I factor this polynomial, my answers, my solutions are going to be within this pool of numbers. Those are my possible answers. Okay, let's try this one. P over Q. Remember, the constant represents P. This is your constant term. And Q represents your leading coefficient. So let's make a list. The factors of P are 1 times 16 will give you 16. 2 times 8 will give you 16. And 4 times 4 will give you 16. So those are the factors of P. The factors of Q are 1 and 3, because 1 times 3 will give you 3. -1 times -3 will give you 3. So let's list my possible factors. Of course, all of these can go over 1. So if I list my possible answer choices, these are all of my possible zeros, rational zeros. And then all of these over 3. So I'll have 1 over 3, so 1/3, 2 over 3, 4 over 3, then 8 over 3, and 16 over 3. So these are all of my possible rational zeros. I listed them all. Okay, so let's put this into practice. First, let me just show you something. If I try to factor this, I would divide these both by x squared. So x squared is on the outside. What's left over is x plus 3. On this side, I can divide both by -2 So I'm left with 3x plus 4. Notice these do not match. So factoring did not work. Regular factoring did not work. So this is where my rational zeros theorem comes into play. That's why it's so helpful. Factoring did not work. So what I'm going to do, step 1, I'm going to list all possible rational zeros using the theorem. So P over Q. The factors of P are 1, 2, 4, and 8. Because 1 times 8 is 8. Oh, I'm sorry. Yes. And 2 times 4 is 8. And so are the negatives. So -1 times -8 is 8. Okay, so you see how we got that. And the factors for 1 are just 1 and -1. So I really don't have to write that. Anything divided by 1 is just itself. So these are my possible answers. So these are my possible rational zeros. What I'm going to do now is I'm going to test some zeros using synthetic substitution. So I'm going to use synthetic division here. 1, 3, -6, 8. And I'm just going to test 1. I like to start with 1. Multiply, add, multiply. Oh, this is a -8. Add, multiply, add. Okay, so I did not get 0 from my remainder. That means 1 is not a 0. Now I have to try again. So let me try a different one. Synthetic division. And I'll try -1 this time. Multiply, add, multiply, add, multiply, add. Yay, I got 0. That means this is a solution. So I know x is one of my, -1 is one of my answers because my remainder was 0. Now, my goal is to reduce this down to a polynomial that I can factor. We started with the cubic. So after I did synthetic division 1 time, this is now a squared. You go 1 degree down. So this is a squared. Now you can keep doing synthetic division here, or you can just go and factor this. So I'm just going to go ahead and factor. 2 numbers that multiply to -8 and add to 2 are 4 and -2. So my factors are x plus 4 and x minus 2. So the answer will be -4 and +2. So these are my 3 answers. So these are my solutions. These are my zeros. And my factors, if it asked for my factors, the factor associated with -1 is x plus 1. The factor associated with -4 is x plus 4. And the factor associated with 2 is x minus 2. So these are my factors. So because I couldn't factor from the very beginning, since I couldn't factor this from the very beginning, I made a list of what possible answers I could have and did synthetic division to test it. So notice, guys, -1 was one of my answers, and that's in my list. -4 was one of my answers, that's on my list. And 2, that's on my list. Let's try another one. So the possible factors of -18 are 1, 2, 3, 6, 9, and 18. All over plus or minus 1, since this factor is 1. But I don't really need the bottom. All right, so those are my possible zeros. Let's go ahead and try factoring. I'm sorry, synthetic division. So 1, 3, -7, -27, -18. Let's just test one. Multiply, add, multiply, add, multiply, add, multiply, add. I did not get 0. So 1 is not a solution. Let's try another one. I'll try -1 this time. 1 is not an answer choice. 1 is not a solution. It is not a solution. So let's try -1. Multiply, add, multiply, add, multiply, add, multiply, add. Great, that worked. You can either stop here. So I know that -1 is one of my answer choices. You can possibly stop here, or you can do synthetic division more. So I just want to show you what synthetic division would look like if you continued. So I know that -1 is one of my answers. I'm going to test another number. And you can start with what remains. You don't have to start with the original one all over again. You can start down here. So I'm going to do, let's do 2. Let's see if that works. 1, 2, 4, 8, -1, -2, -20. That did not work. Let's try -2. 1, -2, 0, 0, -9, 18. That worked. So that means -2 is also a solution. So I'll add that over here. You can continue doing synthetic division and just guessing and checking from our list. You can pick another one. So I found -2 works. We saw that +2 didn't work. You can move on to these. I'm just going to stop here because I know how to factor this. So look, we started out with a 4th degree. When we did synthetic division one time, this result left us with a cubic. Okay, then I did synthetic division another time. This went down to a quadratic. So now I have x squared minus 9 equals 0. Well, I know how to factor that. This is a difference of squares. This is x plus 3 and x minus 3. And you can solve. So my answers are -3 and +3. So I'll add that here. So these are your zeros. Another word for zeros is solutions. You can call these x-intercepts. You can call them roots. So if we just talked about something we learned last week, you can graph these x-intercepts. Okay, so I put them all on my graph, and I know it's a 4th degree, and it's facing up. These are all multiplicities of 1, so you have to go through each point. There you go. That's what that graph would look like. All right, let's try another example. The factors of 6 are 1, 2, 3, and 6. The factors of 2 are 1 and 2. You do this one and this one. Okay, so that means all of these over 1 is the same thing. Now I have to do all of these over 2. All of these over 2. So I'm also going to have 1 over 2. 2 over 2 is just 1, which is already on my list. I'm going to have 3 over 2. And 6 over 2 is just 3. So I don't have to write that again. So guys, those are my possible zeros. I can get rid of this. So that's the list of my possible zeros. So I'm going to do synthetic division. 2, -5, -1, 6. And I just like to start with 1. And that did not work. 1 is not an answer. Let's try -1. So this will be, we bring down the first number. multiply, add, multiply, add, multiply, add. That worked. So -1 is an answer. X equals -1. Now you can continue guessing from our list by doing synthetic division over and over again until you find all the factors. I'm just going to stop here and I'm just going to factor it. So this will be x squared minus 7x plus 6. So if I do an eye chart, I get 12, -7, that's -4, -3. So I'll have 2x squared minus 4x minus 3x plus 6. This is actually kind of long, so I might just choose to do synthetic division. So 2x minus 3 is one of my factors. That's what's on the outside. And whatever matches goes in the other. Now, if I set this equal to 0 and solve, I'll get 3/2 for this one. And I'll get x equals 2 for this one. So those are my 3 answers. X equals -1, 3/2, and 2. These are my zeros. So if you wanted to graph it, you have an x-intercept at -1, an x-intercept at 3/2, x-intercept at 2. And it should look like this, with your y-intercept at 0, 6, because your constant is 6. So that's your y-intercept right there. Okay, now let's move to the Descartes Rule of Signs. When a polynomial function is written in standard form, a variation occurs when the consecutive means it's in order, one following the next. When the consecutive coefficients have opposite signs. So let's look at a variation. Let's look at this example. This is positive, this is negative, this is positive, this is positive. So a variation in signs means right here is a variation and right here is a variation, because it went from positive to negative back to positive, and then it stayed positive. So there's 2 variations. That's what that line means. There's 2 variations in sign. Okay, so what this means, what the Descartes Rule of Signs says, the number of positive real zeros is equal to the number of variations in signs of f of x. So that means the number of positive zeros. So for positive and negative zeros, let's make a table. It says here, the number of positive real zeros is equal to the number of variations for f of x. Well, the number of variations we just said is 2. So I can have 2 possible positive zeros. What else does it say? Or less than that by an even number. So let's just subtract 2 every time. Less than means subtract. An even number is 2. Okay? So 2 minus 2 is 0. So what this is saying, when I factor this, I might have 2 positive answers or 0 positive answers. That's what it's saying. Let's look at this one. Now, it says the number of negative real zeros is equal to the number of variations in signs for f of -x, or less than that by an even number. It basically says the exact same thing, except for one is f of x, and the other one is f of -x. So guys, we're not using this function anymore. We're going to plug in a -x. So we're going to do f of -x. When you plug in a -x, when plugging in a negative x. Odd degrees change. Even degrees don't. They stay the same. Stay the same. You need to write that down. So guys, this is an odd degree. It's going to change. So it was a positive 2. Now it's a negative 2x cubed. This is an even degree. It's just going to stay the same. This is an odd degree. You can imagine the degree being a 1. That's going to change. And that's a constant. That'll just stay the same. Okay? The reason why, if you just want to know why, is negative x times a negative x is a positive x squared. But if you multiply by another negative x, it'll be negative x cubed. So this became a negative. That's why we have a negative here. Odd degrees make things negative. An even degree, as we saw right here, made it positive. A negative x times a negative x gave you a positive x squared. So this became a positive x squared, and then you have a negative in the front. Nothing changed, okay? So just if you memorize that, odd degrees change, even degrees stay the same, you'll be able to do this fairly quickly. Okay, let's get back to the Descartes table. So this is f of negative x. Let's look at the variations. There's only one variation. Here it went from a negative to a positive, so there's only one variation. I can't subtract 2 from 1 without becoming negative. So that means it is certain that I'm always going to have one negative answer no matter what. So these are my possibilities. I can have 2 positives and 1 negative answer, or no positive answers and 1 negative answer. Okay, that's what the Descartes table is saying. Let's try another one. Let's figure out how many positive possibilities I have. So here's a variation and here's a variation. That's 2. Less than that by 2 is 0. Now let's do f of negative x. Odd will change. Even stays the same. Constant, that stays the same. Now there are just one variation. So 1 and 1. I wrote 1 twice because I'm always going to have one negative answer no matter what, because there's only one variation. And I can't subtract 2 from that. One variation. All right, next example. There are no variations. So I'm never going to have a positive answer. If I plug in a negative x value, this will stay the same because that's an even degree. This will change because it's an odd degree. Your constant stays the same. That's 1, 2 variations. So for negatives, I might have 2 answers or none because it has to change by 2. The difference is always 2. Remember our notes, it says, or less than that by an even number. All right, next one. 1, 2, 3, 4. That's 4 changes. Or less than that by an even number. Or less than that by an even number. You just subtract 2 every time, okay? Now, let's figure out what it would be for odd. F of negative x. This will change because it's odd. That will stay the same because it's even. This will change because it's odd. This stays the same because it's even. This is odd, so it'll change. Constants stay the same. So there is only one variation. So you for sure will just have one negative answer. No matter what the positives are, say you have 2 positives, you will always have one negative answer. Say you have no positive answers, you will always have one negative answer. If you have 4 positive answers, you will always have one negative answer, okay? All right, so let's talk about something else. I'm going to add another column to my chart. I'm going to add an imaginary column. Now, this is a 5th degree polynomial. That means I'm going to have 5 solutions. So this is 4 and 1. That's 5 solutions already. That means I don't have any imaginary numbers. So if you add across, 4 plus 1 plus 0 is 5. I'm always supposed to get 5 solutions. Well, 2 of the solutions are positive. 1 is negative. That leaves 2 needing to be imaginary. 2 plus 1 plus 2 is 5. Next, 0 plus 1 plus 4 is 5. So these are your different possibilities. You might have 4 positive answers and 1 negative answer, 2 positive, 1 negative, and 2 imaginary to equal 5. Or when you solve this, when you factor it, you might figure out that you have no positives, 1 negative solution, and 4 imaginary ones. That's how this table works. Let's practice it here. I'll do an imaginary column. 0 plus 2 plus, this needs to equal 4 since it's 4th degree, plus 2 will give you 4. This is still 0, so this is going to be 4. Your rows have to add up to 4 because you need 4 solutions total. We'll do one more. This is a 3rd degree, so each row, when I add an I column in, each row needs to add to 3 because I need 3 solutions. So this one is fine. I have 2 positive, 1 negative, 0 imaginary. That's 3 solutions total. This will have to be 2. Okay, now let's put this into practice. Why do I want to do that? Here's an example. First, I'm going to create a list of possible rational zeros. So the possible answer choices are 1, 2, 4, and 8. This is 1, so I don't have to worry about that. Those are my possible zeros. Now I'm going to use a Descartes Rule of Signs to help me eliminate some options. Here's a sign change, and that's it. I know for sure I'm going to have 1 positive answer. Now let's do the negatives. F of negative x is, this will stay the same. This one changes. This stays the same. This one changes. That stays the same. There's 1, 2, 3 changes. Less than that by an even number is 1. Subtract 2 every time. So no matter what, I'm going to have 1 positive solution because I only had 1 variation for this one. Now, this is a 4th degree polynomial, so this will be 0, this will be 2 because it has to equal 4. Across the row, it has to equal 4. Okay, so let's go ahead and start. I'm going to do synthetic division to figure out some of my answers because I cannot factor this as it is. So I'm going to use synthetic division. Let's just try 1. Here's 1, 6, 7, -6, -8. Okay. Multiply, add, multiply, add, multiply. Excuse me. Add, you get 8. Multiply, add. Perfect, that worked. Let's keep going with synthetic division. I know x equals 1 is an answer. Now, this is where the table comes in handy. Notice, guys, I only have 1 positive answer. So that means I don't have to test +2, +4, or +8 because I already found my 1 positive answer. That makes guessing a little bit easier. Okay? Because no matter if I have 1 positive answer, 3 negative answers, or 1 positive answer, 1 negative answer, and 2 imaginary answers, either way, I only have 1 positive answer. So I'm done testing positive ones. Let's test some negative answers now. So with this, I'm going to test -1. Let's see if this works. Multiply, add, multiply, add, multiply, add. I get 0. Yay, that worked. Okay, you can keep testing more answers. I know that this is an answer, and I know this is an answer because I got 0 from my remainder. That's how I know those are zeros. So I'm going to extend this. I know 1 and -1 are my answers, are 2 of my solutions. I know 1 and -1 are 2 of my answers. I still need to find some more. I need to find 4 total since this is a degree 4. All right, I'm just going to go ahead and factor this. I'm not going to keep doing synthetic division. I'll do an eye chart. 2 numbers that multiply to 8 but add to 6 are 4 and 2. So these are x plus 4, x plus 2. If you set them both equal to 0 and solve, you get -4 and -2. So -4 and -2. So guys, look. -1, -4, and -2. Those are my 3 negative zeros. 1 is my 1 positive 0. And that means I'm left with no imaginary zeros. So you need to circle which possibility it was. It was that top possibility. It wasn't this one. We didn't get any imaginary ones. And also notice -4 and -2 are also in my list of possibilities here. Last example, I'm going to list all the factors of 4. 1, 2, and 4. And the possibilities or the factors of 2. 1 and 2. So that means to my list, I'm going to have 1 over 2. 2 over 2 is just 1, and 4 over 2 is just 2. So those are all my possibilities. Those are my possibilities there. Okay, moving on, I'm going to do a Descartes table. There is a variation here, and that is it. So I only have, for sure, 1 positive possibility, 1 positive solution, for sure. Now let's plug in a -x. This will stay the same. This will change. This will stay the same. This will change. This will stay the same. So that's 1, 2, 3 variations. And less than that by 2 is 1. This is a 4th degree polynomial, so I know this will be 0 and 2 so that they can equal 4. All right, let's go ahead and do synthetic division. I do synthetic division on the original one, not that one. So let me erase that, get that out the way. We're not using this anymore. We're done with that problem. All right, so let's do synthetic division on 2, 3, -7, -12, -4. Okay, I'm just going to test -1. So I get -2, 1, -1, -8, 8, -4, 4. Yay, that worked. I tested a negative number first this time because maybe it's this one, and there's 3 possibilities for it to be negative. So I have a greater chance of finding my answer if I test a -1 first. Okay, so that's one of my answers. Let's try -2 this time. Maybe that's an answer. -4, -3, 6, -2, 4, 0. Yay, that worked. So that's an answer. You can stop here and factor it. I'm going to try to keep going. I think synthetic division is quick. So let me try -4 this time. 2, -8. I don't think this one's going to work. Yeah, that one did not work. It's way too big. Okay, so -4 is not an answer. I might give up here and just do factoring. Let me try one more. I'll try 1. Let's just do that. 2, 2, -1, nope, I didn't get it. Okay, I'm just gonna go ahead and factor now. I got it down to a polynomial that I know how to factor. So this becomes, we started out with the 4th degree, so this is the 3rd degree, this is squared. All right, so I'm gonna do -4, -3, that can be -4 and +1. So this will be 2x squared minus 4x plus x minus 2. Split it down the middle. Divide by 2x. Those 2's will cancel. I'm left with x. Divide these both by 1. 1's on the outside. These match. That means it works. So 2x plus 1 is in one of your parentheses. That's what's on the outside. And x minus 2 is in your other parentheses. If you set these both equal to 0 and solve, you'll get subtract 1, right? And then divide by 2. So you get -1/2. And then for this one, you get x is 2. So my answers are, I'll put it up here. I got -2, -1, -1/2, and 2. Those are my zeros. These are my zeros. And look, it matches this. I got 1 positive answer and 3 negative answers. No imaginary ones. And what did we use? We used the Descartes Rule of Signs to figure out the table. And we used the Rational Zeros Theorem to figure out possible rational zeros.